Hello all, today we're going to be talking about simplifying radicals with help from the graphing calculator. Now you can't simplify a radical only in the graphing calculator. You have to use some mental math here as well, but we can use the graphing calculator to help us create a list of factors that multiply to get 24 that's under the radical. So the idea is that a radical can actually be split up into 2. So if I have the square root of a times the square root of b, this is actually the square root of a times b. So we're essentially working this backwards with the idea that 24 can be represented by two numbers multiplied together, and then I can separate them with the radicals. So we're going to start by taking 24 off to the side and creating a list of numbers that multiply together to get 24, which are called factors. So I'm going to start by going to y equals, and this is how we get our list of factors in the graphing calculator. If you need more assistance on this, I will post a link to my video up here in the corner. So I start by typing in 24 divided by x. I'm going to go to second window, change this to ask mode, and go to my table. So I start with 1. 1 works, 2 works, 3 works, 4 works, 5 doesn't. I delete it. 6 also works, but I have my list complete now. So, based on this list, so I'm just going to copy this down onto our paper here, we have to determine which one of these is the highest perfect square that will evaluate into an integer. So, we can start by saying, well, what about the square root of 24? No. The square root of 12? No. The square root of 8? No. The square root of 6? No. These are not perfect squares. But when I get around to the square root of 4, the square root of 4 is in fact 2. So this becomes a 2. So I take the entire factor pair, the 2 and the square root of 6, and that is my simplified radical. Okay, so one more time with number 2 here. I'm going to start by making a list of factors for 50. So I'm going to use the graphing calculator, and I'm going to take a look at 50 divided by x. Go straight to my table since it is in ask mode already. Start over here. 1, 2, 3 doesn't work, 4 doesn't work, 5 works, 6, 7, 8, 9, 10, and 10 is our repeat here, so I can delete the rest of this list. So, based on the list I just created of the factors, I need to go through each factor from highest to lowest and determine if any of them are a perfect square. The square root of 50 is not. The square root of 25 is. The square root of 25 is actually equal to 5. So I have my matching pair of the square root of 2 times the square root of 25, but the square root of 25 becomes 5, and I can place that in front of my radical to have my simplified version. If you want to test the validity of your choice, you can actually go into your graphing calculator, type in the square root of 50, and this should be equal to 5 square roots of 2, which it is. So that's how you know that you arrived at the right answer. You can also test this in here. When I created my factor chart, the square root of 2 times the square root of 25 is also the same. They're all equivalent. So let's take a look at number 3. So once again, I'm going to write out a list of factors, 1 and 32, and go into the graphing calculator to grab the rest of them. 2, 3, doesn't work, 4, 5, 6, 7, and 8 works, but I already have it here, so I'll delete my repeat. So I'm going to write this down, 2 and 16, 4 and 8. So it's very important to recognize that you always have to start with the largest number. So the square root of 32 doesn't work. The square root of 16 does. The square root of 16 actually becomes a 4. So I'm going to write 4 square roots of 2. Be careful that you don't select 4. 4 is a perfect square. However, it is not the greatest perfect square I can pull out from this radical because 8 actually is comprised of the square root of 2 times the square root of 4 as well. So that's why you always want to start from the largest and make sure you pick the best choice. All right, I hope you enjoyed watching an A. Heisig creation. Have a nice day. Bye-bye.